Good morning, everyone. Today's session is going to be very important. In this session, I am going to discuss regular expressions properties. So, till now, I believe that you are comfortable with regular expression. You know that what is the use of regular expression, how to write regular expression for different languages, right? We have already seen some examples. So, let's discuss the properties. There are few very important properties that you must know in order to attempt the questions correctly. Okay, so the very first property, let's say if there is a regular expression R1 and there is a regular expression in R2. If we perform union operation, so that I'm highlighting here the union operator. So R1 or R2, or if I write R2 or R1, both the resultant regular expression will be equal. So there will not be any difference. That means they are commutative. So this union operator is commutative. Order of regular expression, if you change, the final resultant regular expression will still be equivalent. Similarly here, if you are having let's say three regular expression R1, R2 and R3. So if you first perform union on R2 and R3, then you perform union on R1 and then the resultant of this. Or if you first perform union on R1 and R2 and then you get some resultant here and then you perform the union with R3, then also the resultant regular expression will be equivalent or same. So this is also associative. Then the next property is, let's say we perform the distributive kind of property. So if R1 we are concatenating with this regular expression which we are getting by performing union. Plus means union, right? So we can write it like R1 dot R2 or R1 dot R3 as we write in mathematics or digital algebra, right? Boolean algebra. So we can write like this. That means this concatenation is, you can say this is a kind of left distributive property. So from the left side, this concatenation can be distributed over union operator. Similarly, if we put concatenation at right side, then also it can be distributive over union operator. So we can write R1 dot R3 like this, and we can write R2 dot R3 like this. Still, these two things will be, these two resultant regular expression will be equivalent or same, right? Now the next important property, if we are performing concatenation, so we want to concatenate one regular expression R1, another regular expression R2. If we change the order, the resultant regular expression will not be same. So that means concatenation operator does not support the commutative property. You cannot change the order. If you change the order, let's say R1 was representing, a regular a string like AB, and R2 is representing, let's say AB, same. Okay, so if you are performing R1 dot R2 or R2 dot R1, they will be same, but it will not be the case all the ways. So if I say R1 and R2 both are different, let's say this is BA, in that case this will give you different string and this will give you different string. So if this is not always true, we are saying it is not equal to, right? Then the next is R1 concatenated with R2. So either you first concatenate these two things, or you first concatenate these two regular expression and then resultant you are concatenating with this R3. This will be equal. So this is a kind of associative. So you can say the concatenation operator is associative, right? But concatenation operator is not commutative. The next property is, let's say you are performing distributive property union over concatenation. So please do remember, union operator is not distributive over concatenation operator, but concatenation operator is distributive over union, as we have seen in the previous example. So if you want to distribute this plus operator, that is union operator over this, if you want to write R1 plus R2 concatenation with R1 plus R3, it will not be equivalent because this union is not distributive over concatenation. Similar case here, if right side also if you apply like this thing, and if you want to write R1 dot R1 plus R3 concatenation with R2 plus R3, then it will also not be equivalent. So please do remember. And then let's say the union operator demonstrate idempotent law, in which if you perform the one regular expression R1 and you perform, let's say, concatenation or union with the same, right? So if you perform the union R1 union with R1, it will give you R1 only. Okay, so if you say all these strings which R1 can generate or all these strings which R1 can generate, obviously you will get the same set. But in case of concatenation, there will be problem. So if you consider R1 is, let's say, a language A or a string is AB, but if you write R1 concatenation with R1, it will not give you AB, it will give you AB, right? So I hope you can understand this concatenation does not satisfy the idempotent property. Then the next is identity property. So what is identity? Identity, also known as identity element or neutral element. What is neutral element? An element, if you perform the operation of that element with a regular expression, you will get the original regular expression. That is neutral element or identity element. Like phi. So if you perform union operation of a regular expression R1 with phi means null set, you will still get the same regular expression. Like if you perform the union operation of phi with R1 after changing the order, then also you will get the same regular expression. Now this null or epsilon. So if you concatenate null with any regular expression, either from left side or right side, you will get the same regular expression. So this is very important property. Please do remember. Now one more, like annihilator property. So sometimes what happens that you are having two regular expressions, okay? And let's say if you assume that R1 generating a set of string which is subset of R2. So if you write like R1 or R2, it will obviously give you R2 because R2 is the superset of R1. Okay, because R1 is not going to give you anything extra which R2 cannot generate. So R2 can annihilate the R1, right? Similarly here, I am saying R1 and the alphabet star. That means every possible string, this meaning is every possible string over a alphabet on which R1 is also defined. So if every possible string you are already taken here, that means I can say R1 is the subset of this set. So if R1 is the subset, if you perform union here, then you will get alphabet asterisk because this is the superset. Now this is very important, this last one which I have written, so let me highlight this. You please do remember this. If you concatenate phi or null with any of the regular expression, you will get phi only. So phi is having the capability to annihilate any of the regular expression, only phi will left. Okay, so please do remember all these important properties. Thank you everybody for connecting. See you in the next class.